Calculus! This is AP Calculus Lesson 5-4, Unique Power and Exponential Anti-Derivatives. Today is one of our longest lessons ever. Let's talk about why we even need to talk about a new rule, because we are learning about a new rule today. Let's go ahead and deal with this guy. Let's go ahead and use U-Substitution, because I think we need to practice. Yesterday we all decided to do taxman. U-Substitution, I need two things.
U du over dx.
Perfect. And before I begin with that, I noticed, and this is slightly based off of yesterday, so Ben, you're getting your new information here since you missed it, and I totally forgot that today is November 16th, 11/16. There we go. So I need to turn this into a non-fraction because fractions gross us out here in this class, because that means inverse quotient rule, which doesn't exist. So how do I turn this into a non-quotient?
You do 12 times 3x plus 1 to the negative 1 times dx.
Perfect. All right. Should have done that first. Anyway, let's come back down here to our u. Ben, what is our u?
3x plus 1.
Arrow. Derivative of u.
3.
There it is. All right. Next steps. What am I doing?
We plug in.
Close.
Oh, cross multiply to find dx.
Cross multiply, find dx, and dx happens to be what, Rochelle?
1 over 3 du.
1 over 3 du. Do we all agree? Yes, we do? Okay. Wasn't quite sure. All right, so moving on, let's go ahead and now plug in as Rochelle said. Ben, you want to do that for us? Do the honors.
Yep. Dx equals 1/3 of 3.
You want to just go ahead and rewrite this while substituting in? So I still have that 12 out front, right?
Yeah.
12 times what?
3.
Careful.
3x plus 1.
No, 3x plus 1 is now u. So I just have u here.
Oh, you just plug
U's to the power of
negative 1.
all of that times. It's not dx anymore. It is now,
1/3 du.
there it is, 1/3 du. All right, we plugged everything in. We can go ahead and simplify this too. Let's go ahead and simplify this. That turns into integral of what arrow? The 1/3. Or 1/3 and 12, can you simplify those? 4u negative 1 du. Perfect. Now we have a nice simple integral. We can take the antiderivative. Anyone's game? Who wants to do that?
Would it be 4 times u to the negative 0?
Yep.
Du plus c. My bad. All
Wait.
over 0.
If you're you can't divide by 0.
Whoa, what? We can't do this!
It's just 1 though.
It's just 1 though? What do you mean?
Well, because something at 0 is 1.
Are you talking about u to the power of 0?
Yeah.
Yeah, that would be 4 on the top, so 4 divided by 0, and we've broken one of the sacred laws of mathematics. Don't divide by 0. So yeah, we need a new rule. Can't divide by 0. So here is your rule. It has a red star here. I had to condense it all together, so spacing is a little bit off. But here is your red star rule. If I have some number out front, and I have my inner, which is u to the negative 1, if you ever see this form, a could be any number. It could be 1, which means there is no a, I guess. If you see something like all of this du, of course, and I'm trying to take the integral of it, this is equal to a, the same thing, times the natural log of u. And don't forget your
C?
plus c. Yeah. There it is. Box it, star it, highlight it. That is an important rule. You will need to remember that for the rest of your mathematical lives as long as you are doing calculus. Definitely for this class. All right, so if you ever see anything to the power of -1, It is the natural logarithm. Let's go ahead and see an example. So that means we could have solved this example up here. Let's go ahead and solve a slightly different example. All right, what are we going to do? First of all, are we going to use taxman, U-substitution? Should we get some more practice with U-substitution? We seem a little bit... All right, U-substitution. What two things do we need again? U and du dx. All right, what are those things? Anyone?
U is 2x minus 1.
And someone aside from Rochelle, du dx is 2. Because what we're really doing here is we converted this. Arrow, you want to convert this for us? I always miss that first step.
6 times 2x minus 1 to the negative first, or negative 1, well, anyway, dx.
There it is, yep. All right, and substituting those in, we get what?
Wait, but we already know the format is already obvious from the important rule. Okay, you know, never mind. You can do it. Figure it out later.
Okay, Rochelle, what's up?
6 times u to the negative 1.
So you're already jumping ahead. Yeah, did you already solve for your dx?
Yeah. Dx equals 1 over 2 du.
1 over 2 du. Are you guys seeing the shortcut already?
Just flip it.
Reciprocal and then du, yeah. And the reason for the reciprocal is because you need to take the reciprocal of the left, which means you need to take the reciprocal of the right, and then multiply both sides by du. Any whoosies, let's go ahead and substitute that in. As Rochelle said, we are going to have the integral of 6. Well, I think she even simplified it further than that, but I'm going to go ahead and just write out all my steps, which is going to be 6u to the negative 1, and plugging in 1/2 du. I get 1/2 du there. And then, Rochelle, can you tell us how you simplified that?
I wasn't telling you to simplify before, I was telling you that one.
Oh, you were telling me that one? I thought you
Yeah,
were...
but it would be 3 times u to the negative 1 du plus c. Oh, not yet.
Yeah, and I forgot the integral too. The integral of 3, I don't know why, 3u to the negative 1 du. And as a note to people watching this on YouTube, the sound in the background is a 3D printer. I accidentally am printing something too big. All right, moving forward. Now that we know how to take the antiderivative because of this rule, let's see if we can actually do that. Taking the antiderivative gives us, let's switch the color to. Well, I'm taking the antiderivative, so those two go away.
Oh, so it'd be 3 times u to the 0 power over 0 plus c.
So we can't do that, right? So we can never divide by 0. So we have to use this new rule. Whenever I have something au to the negative 1, so I have 3u to the negative 1.
Would it be 3 times the natural log of u?
There it is. Natural log of u plus c. And then I guess we need to substitute that actually back in. So 3 natural log of what? 2x minus 1 plus c. There it is. All right, I'm going to pause here to make sure that we all understood how we are using our new formula. Making sure we all understand that. Everyone's nodding their heads and saying, yeah, all right, let's see another one. All right, let's actually do the first step correctly. Ben, go ahead and do this one for us. This turns into integral of
4 times the quantity of 1 minus t to the negative 1.
And what else? dt. There it is. All right. Rochelle's always telling us our u's and stuff, so let's give this arrow.
U is 1 minus t.
1 minus t. And keep going on.
The derivative of u is negative 1.
Negative 1. du dx is negative 1.
Wouldn't it be du dt?
It is
it's
du.
not negative 1 at all. Wait, I don't.
It is dt. Sorry about that. Yeah, that's a
It is
teacher error.
negative 1 because, yeah.
Have you been logging these, Rochelle? That's just points that you could be getting for your grade. I can find you another one if you can't find it. Yeah?
I have it.
Just,
So much
okay.
effort to open Finder.
All right. And I really hope that you are starting to think that this is a slow process and are skipping steps, as long as you're skipping those steps correctly. I could have just jumped right here into my U-substitution because I know what would happen as long as I know to multiply by that negative. This is going to turn into what? Integral of
4 times 1 to 1 minus, oh no, u, my bad, to the negative 1 times negative 1 du.
Yeah.
I was about to say 1 over negative 1.
Which is technically correct. Yeah, I guess the step that we skipped, I should just write down in case we need it, is that dt was equal to negative 1 du. So that's the substitution that we're using right here. And just to make sure that this is as clear as possible, that's a negative 1 being multiplied, not subtracting, so have that parentheses in there. And that's going to turn into a little bit more simplified integral of negative 4u to the negative 1 du. All right. And we can take the antiderivative. Can you take the antiderivative and plug in the u all at the same time? Let's see if we can skip a step.
It would be 4 times u, no, 4 times the log, natural log of u plus c.
It's negative.
Yeah.
Wouldn't it be?
And if you plug in the u,
Oh,
it's
yeah.
1 plus 2. I'm 1 minus
So
2.
du goes away, but you still have negative 1, right?
Yeah.
Hey, wouldn't it be positive? Like,
Why would it be?
because you're multiplying negative 1 to negative 4.
So you're actually not doing any multiplication. You're just using this rule where the a stays the same.
Oh,
Yeah, but
okay.
it
And instead of putting a u, you were right and say natural log of u. Let's go ahead and just skip that step. U was 1 minus t. We'll put that in right now, 1 minus t. And don't forget your
C.
plus c. Yep. All right, so these are super common on the AP test. They love throwing these at you. I've seen them many times. John has seen them many times. That's why he put them on the notes. And this thing is equal to, go ahead and tell me. 1 over x is directly equal to, when I take the integral of 1 over x, it's always equal to
ln of x
natural log of x
plus c.
plus c. You just need to have this in your back pocket. Don't think about, okay, I need to convert it to x to the power of negative 1, and then remember the rule. Just as soon as you see 1 over x, be like, natural log, done. Same thing, someone other than Ben. When you see 1 over t, this turns into
Natural log of t.
natural log of t plus c. Yes, there it is. So I'm just going to make a teacher note. I could do that a little bit better. Memorize this. You'll be seeing them quite often. It'll be like a random multiple choice, and you could just have it done in like 2 seconds. All right. Or it will be used as part of the multiple choice, and you can have it done in 2 seconds. Okay. We have 2 more examples and some notes to get through. What's up?
Okay, I just wanted to check in. I'll come whenever you test, but like, and then I guess we can work at break as well for like the test.
Sounds good.
Okay, thank you.
Exponential antiderivatives. So when I take the derivative of e house, this is something that's kind of cool. You guys are just following along with me. This turns into the integral of 2 times something, something, something. We still need U-substitution because we have an inner of 4x. Dinner, therefore, is
Would it be e to the 4x power times 4?
so you're going forwards. You need to go backwards. And instead of times 4, you need to divide by 4. But yeah, that's the correct intuition. But what is our dinner? Inner is 4x, therefore dinner is,
E to the
just take the derivative. Derivative of 4x. 4. Is 4 1?
No.
If dinner is not 1, you always have to use taxman or U-substitution. So let's do this one really quick, and because it's Friday, I'm just going to rush through this. U is equal to 4x. Our du dx is equal to 4, which is not 1, therefore we actually are using this method correctly, and we know that we need to solve for dx, which is 1/4 du. which means this is now going to be 2e to the power of what? U. There it is, and then that dx turns into a 1/4 du. And that's where Rochelle was thinking ahead. Oh, just multiply by 4 because that's e house. When you're going backwards, that's divide by 4. All right, so simplified a little bit further, that's going to be the integral of e to the u times 1/2. And don't forget your du. And when I take the antiderivative of e house, it is e house. It's just like going forwards, it's going backwards, it's the same. As long as you don't have some dinner not equal to 1. So now when I take the derivative, I guess I should be switching colors on each of these steps. When I take the derivative, or sorry, not derivative, integral, it is going to be what? Same.
1/2 e to the u.
Yep, same. 1/2 e to the u. Don't forget your, plus c. Rochelle's on it.
So whenever there's exponents, whenever you have exponent, you always have to focus on that in order to see if x equals 1
Yeah.
or not.
To see if the derivative of that exponent is 1. Yeah, and that's dinner.
What would happen if it did equal 1?
If it does equal 1, you can just do this step right away. Just automatically take the antiderivative. Yep. Good question. All right, and substituting back in for u, this is our final answer of 1/2 e to the power of 4x.
Times it by 4?
Plus c.
I mean,
Done, done, done. No, that's good. We're participating. You think you can do 2 examples? Walk me through them as fast as you can. What time do we get out of here? We get out of here on Friday at 10 o'clock, which means we have 18 minutes left. But the homework is a packet. It's front and back 2 pages, so 4 pages, I guess. So that's why I'm trying to rush. I want to give you
At least we have all Thanksgiving break.
That is true. It lined up nicely. Although the next lesson is also the same length for homework, but let's avoid that. Example 3.
there's been a couple times where it's been
Is
Guys, we are
is dinner 1? Is dinner 1?
No.
No,
What is dinner?
6.
All right, let's go ahead and do it.
U equals 6x and du over dx equals 6, which means dx equals 1 over 6 du.
1 over 6 du. I tried keeping up. There it is. So this now is the integral of what? Using our U-substitution.
It would be negative 1 over 3 e to the u power times it by 1 over 6 du.
Everything you have said so far is correct. Let's simplify this a little bit.
It would be negative 1 over 18 times eu to du.
Yep. All right. Let's let Ben or Arrow take the antiderivative.
So it's going to be. Oh, it's just going to be negative 118 e to the u.
E to the
Plus c.
something plus c. Let's go ahead and just skip the u because we know that's u. E to the,
6x.
there it is, done.
Can we do that in the work?
Yeah. AP graders and me, depending on the type of problem, are okay if you skip steps. As long as you just don't skip right to the answer, then I'm thinking that you use Wolfram Alpha or something like that. I know that you guys aren't, but... All right. Uh-oh. Why is this problem gross?
Because there's 2 types of exponents.
Fractions, yeah. And this is also... it's gross that way too, but I guess the grossest part is fractions. That really grosses me out. So let's go ahead and rewrite this without fractions. That gives us what?
2t times e to the 4t to the second power.
Nested exponents. Always fun. Why was I about to write dx?
Wait, yeah.
We did forget something. Arrow.
No, Rochelle did it.
Negative what? Is it negative 4 or negative 2?
Both?
It's
What do we
just
think?
negative
Negative 1.
Just one.
This is 1.
It's just that one.
Oh. Okay.
Wait, you can just make that negative?
Yeah.
You don't have to do a negative 1 outside?
It's a negative 1.
Well, I guess
Oh,
'cause-
yeah. So
Oh, you don't, because exponents will just multiply it.
negative 1, you're right. I was actually skipping a step. I didn't even realize I was skipping a step. That's my bad.
But yeah, you put negative 1 outside and it would just multiply it.
Yeah, so if this is to the power of -1, something to the power of something, powers multiply, this becomes -4t. Is that okay? Do we remember our rules of exponents? If you don't remember that, write this rule on the side.
Yeah, well, -1 wouldn't multiply to 2 as well?
It doesn't, because in order to multiply by that 2, I had to have to multiply by e to the something, and then that something, if this base was the same, that 2 is basically untouched unless very, very specific things happen. But here's your rule. If you have x to the power of a times, or x to the power of a to the power of b, this is equal to x to the power of a times b. That's your rule that you need to remember from pre-calculus and algebra 2. Whenever you learn this, it was sometime last year. That's your review. Okay, so now we have this beautiful thing. You want to try using TaxPan and see if it works? Because you've been using U-Substitution at every step. All right, let's try it. What do we need for TaxPan?
U, taxman, and U prime.
And U prime. Chung, chung, chung. U is
-4t squared.
-4t squared. What is TaxPan? Someone aside from Ben? Arrow? Rochelle?
2t.
2t. He's knocking at the front door. And U prime, therefore, is?
The natural log.
Ooh,
No,
careful.
Sorry.
Just looking at this
It
guy.
would be -8t.
-8t. That means we're going to pay TaxPan with what fraction?
-1/4.
-1/4. Yep. And when we rewrite TaxPan, which is going to be this step right here, TaxPan.
Wait, how do we get -8t for u prime? Because you do.
Because
You,
you multiply 2 to -4.
wait, no, you add 1 to 2, and then divide. Oh no, it's prime, not.
Yeah, you're taking the derivative. You're going backwards and she was going forwards. Make sure that you're going forwards from u to u prime. Simple mistake, and we're going to be making lots of those, so just be ready to make more of those. Am I going backwards or forwards? Integral of, what is the paying TaxPan version of this problem?
-1/4 to the times u to the. I don't know that. Oh, time to the.
It's not quite u.
It's very confusing.
All right, well, can I substitute out the e? Is anything out here e?
No.
Nope, just leave it then. Is -4 or t or squared, any of that can I sub out?
Yeah.
What can I sub out?
U.
U? So I should just write u here, or
U to the second power.
u to the second power like that? What do you guys think? You think no?
No, because u is our -4t squared.
So just like that then?
Yeah.
Yep, you're correct. Yeah. U is all of this, so all of this is just u.
The way that you respond to my answer just makes me not even say anything.
Well,
It makes me feel like I'm getting it wrong.
confident even though.
Yeah,
it's
be
like-
confident,
like-
and I don't want to give away the answer by me being like, oh yeah, you got it, or no, you're wrong. I'm just going to passively sit here until you figure it out.
No, but
Which is
this
interesting
is
because
kind
then
of
if we actually get it wrong,
It's
it's
kind
gonna
of
be like
confusing.
Mr. Brown.
And that way, if I accidentally make a mistake, I can pretend that you made the mistake, and then, oh yeah, what a good learning opportunity this is. Okay, so this is e to the power of u, and I have something out here.
DT.
Not dt anymore, because no, you're right. Oh my gosh, what am I doing? We're doing U-Substitution. We don't need to do U-Substitution. TaxPan is even easier than that.
Yeah, you don't substitute.
Just leave it like that. It's that easy. And then derivative of e house is e house. Therefore, derivative of e house is e house, but the integral of e house is also e house. So integral of e house is e house. That means my integral is
-1/4 e to the -4t squared.
We'll see.
e
Right, I always forget this.
4t squared plus c. What's going on here? I need to see my notes. There it is. Box it. Done. Any questions? I've taught this lesson only once before, but I'm so used to just calculus now that I don't look at my notes anymore. I just want to make sure that it's roughly the same as what we were doing last year. Yep. All right. Go ahead and do your summaries.